All right, let's begin. So here's the equation. That's the parabola. And at x equals to 2, there is a tangent, and that's given by this green line. So it's all about this equation of the tangent. So the first question is, what is the gradient? So we can figure out the gradient of the tangent by differentiating this parabola, this quadratic equation right here. Then we can find the expression for the derivative. So the derivative is given by 4x plus 2. So if you differentiate that, that one comes out. This one comes out as well. So differentiation 2x is just 2, and differentiation of 2 is just 0. So the derivative is 4x plus 2. So if you plug in any point, so for example, if you plug in -3 in here, then we can find the gradient of this tangent. If you plug in point 0, x equals 0, then we can find a gradient of that tangent at that point. We want to plug in x equals to 2 because the x value of this tangent is 2. So we plug that in, then we can figure out y dash is equal to 8 plus 2, so that's equal to 10. So that is the gradient of this green line tangent at x equals to 2. Now the second question is, what is the y coordinate? So we can see that we can simply plug in x equals to 2 into the original equation for the quadratic equation. So we plug that in here, then we get y equals to 2 times by 2 squared plus 4 plus 2, so that gives us 8 plus 4 plus 2, so that gives us 14. So that value there looks like it's 14, and it is indeed 14. So that point is 14, so the coordinate, the point of contact between this tangent and this parabola is 2, 14. Now C. What is the equation of the tangent? So that's given by this equation of straight lines. So any straight line can be given by this equation, x minus x1. So this one is more popular, the gradient intercept form. So if you want this one, if you like to do it with this one, I can show you that method as well. But this one is actually a bit better, I think, because you don't have to like find c and then put it back into the equation. So I'll show you the difference between these two. So this one is used when you know the gradient and you know a point that the line goes through. So the point that the line goes through is given by x1, y1. So we can see that this one is going through 2, 14, and it's got gradient of 10. So if we simply plug in y minus 14 equals to 10, that's the gradient, bracket x minus 2, and we simply expand them out. That's 10x minus 20, so you move the 14 to the other side, y equals to 10x minus 6. So that's the equation that describes this line. So you see, this value here is only giving you the gradient value. It's not giving you the equation. It's only after you plug it into this formula here, which is an equation of a straight line. Because this is a straight line, you have to use an equation of straight line. It's only after you plug these values into. So you have to plug in the x value here. We found the y value here, that goes in here, and the gradient goes over here. Then you can find the equation of the tangent. You can also use this one here. So we know that y equals to, this is the gradient, so gradient is 10, so it's 10x plus c, and we have to figure out what c is. And this is not going to be 14, because 14 is, the c value here is the y-intercept, isn't it? So we need to find this value here, but we don't actually know what that point is. That's the y-intercept. So all we need to do is just plug in a random point that this line goes through. So we know that this one is going through 2, 14. So we plug in 2 and 14 into right here and right here, then we can find c. So 2 here times by 10, and then 14. So 2 and 14 is what this line goes through, definitely. And this is a 14 minus 20 equals to C. So therefore, C is equal to minus 6. And you plug that back into this equation, then you find that y equals to, so don't worry about this bit here, sorry. Y equals to 10x minus 6. Okay? Yep, so that's the answer, guys.